This week, we're going to talk about the design of data. And what we're going to see is that the design of data really turns out to be a point of leverage in designing programs. Because when we design data, we make decisions about all the functions that later operate on that data. But before we get to that, this video covers conned expressions, which are a new kind of expression in Racket that's going to let us program conditional behavior where there's more than just two cases. I have the constarter.racket file open from the lecture page. And let's just look at this file quickly. It starts by defining three constants called I1, I2, and I3. And they're all three rectangles. And let's see, one is 10 wide and 20 high, and the I2 is 20 by 20, and I3 is 20 by 10. So these are three rectangles of different shapes. And now here's a function design, and the function consumes an image and produces a string. And let's see, it produces the shape of the image, one of tall, square, or wide. And these three examples / check expects really help me understand this function. If I ask for the aspect ratio of I1, I get tall, whereas for I2 I get squared, and for I3 I get wide. And reading through the rest of this, there's a stub and a template that are commented out. And now when we look at the definition of the function, what does it say? It says, well, if the height of the image is greater than the width of the image, then produce tall. That's this whole if there. And that's its question, and that's its true answer. On the other hand, let's see, its false answer is another if that asks if the image height and width are equal, produce square, otherwise produce wide. So this function design works, and if I run it, I'll get what I want. But there is something I'm not entirely happy about here. If you think about this function, there are really three cases, right? There's the tall case, the square case, and the wide case. And those three cases really feel like they're parallel to me. They feel like they're corresponding cases. Whereas when we implement them here with if, we end up having one case, tall, which has two other cases, square and wide, kind of inside of it. And that doesn't feel quite right. It doesn't feel quite right to have one case with two inside of it as opposed to three parallel cases. So what we're going to learn in this video is a new mechanism called conned. That's what's called a multi-armed conditional. And that is something we can use when we want to make an expression that has different behavior depending on the answer to predicates. But there's more than two different options. So here we go. Let's do it to this one. Let me first show you a new trick. If I do sharp sign semicolon, that's going to comment out the entire all of that stuff. It basically comments out from balanced parentheses to balanced parentheses. It's easier than putting a semicolon before each line. And now let's redo this function. I'll say define aspect ratio image. And what I have is three cases. So what I'm going to do is I'm going to write conned. And then there's three cases, and each case has a question and an answer. And there's three of them. So I'll just copy that like that. Oh, and I spelled the name of it wrong. Now notice something here, which is that I'm using square brackets instead of round parentheses around the question and answer pair. That's just a convention to make the question and answer pairs stand out better, particularly when they get larger. Square brackets and round parentheses are really treated the same by Racket. Square brackets balance each other and round parentheses balance each other. You could use round parentheses here, but square brackets just makes it look a little bit better. Now what's the question for the first case? Well, the question for the first case is actually right here. I'll take that and I'll replace that question with it. And if that question is true, then what's the answer? Well, the answer is right here. Tall. And what's the question for the second case? Well, the question for the second case is right here. And the answer for the second case is right there. And then what's the question for the third case? Well, the third case is the last case. It's the in all other cases case. And so there's a special question that we could put there called else, which means if it wasn't the first one or the second one, just do this. And the answer for the last case is wide. Let me first run this to make sure I haven't made any mistakes. I haven't, and it's working. And so the way I want to read this is it says, gee, there's multiple conditions. If image height is greater than image width, then produce this result. Evaluate this expression and produce that result. If image height is equal to image width, evaluate this expression and produce that result. Otherwise, or else, evaluate that expression and produce that result. And that's kind of nice. What that gets me is multiple questions, kind of all at the same level of nesting, all at the same level of importance in some sense. So cond is a good thing to use for multiple case expressions when there's more than two cases. You can use if and nest them the way we have up here, but it tends to read more easily if you use cond when there's more than two cases. Now we'll do the usual thing and look at the rules for forming a cond expression. It's just open paren cond, and then one or more question-answer pairs, where each question-answer pair is open bracket, a question expression, and then an answer expression in a closed bracket. And all of the question expressions have to produce a Boolean, except the last question expression, which is allowed to be the special word else, which is going to mean if you get to this question-answer pair, definitely produce this answer.